Day 720 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2615, sum of distances. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero index integer array nums. There exists an array R of length nums.length where R of I is the sum of the absolute value of I minus j over all j such that nums of j is equal to nums of I and j does not equal I. If there is no such j, set R of I to be 0, return the array R. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input nums equals an array of integers 1, 3, 1, 1, 2. Our output is also an array of integers 5, 0, 3, 4, 0. So let's see how they got this output from this input. So first thing we're going to do when I is equal to 0, so that means when we're looking at index 0, which is this index right here, this 1, it says nums of 0 is equal to nums of 2 and nums of 0 is equal to nums of 3. So this 1 right here is also equal to this 1 and it's also equal to this 1, right? They're all 1s. We have 3 1s right here. Boom. Then it says therefore R of 0 is equal to, so this R of 0, remember this was nums of 0. Now we're looking at R of 0, which is our output. So R of 0 is equal to 0 minus 2, or the absolute value of 0 minus 2. We get the absolute value of 0 minus 2 because nums of 0 is equal to nums of 2. So that's where this 0 and 2 comes from. We get the absolute value of that, which is 2. Then we get the absolute value of nums of 0 and nums of 3 because they are equal as well, right? This and this. So we do 0 minus 3. So once we do 0, the absolute value of 0 minus 2, which is 2, plus the absolute value of 0 minus 3, which is 3, we get 5. So we put 5 right here in our R, which is our output, right? Boom. So that's where this 5 comes from, but we still need to do the rest of these, right? So that's how we got the 5. Then now we're looking at index 1. Index 1 is 3. It says when I is equal to 3, R of 1 is equal to 0 because there is no other index with the value of 3. So in this case, in nums, there's only 1, 3. Since there's no other value for us to subtract or find the distance of, we could just put a 0 in this R array. So that's where the 0 comes from because there is no other 3 here to subtract from. So we just put a 0. Like it says right here, if there is no such j, set R of I to be 0. Boom. So then now we're on I of 2, or I equals 2, which means we're on index 2. When I equals 2, when it's just I, that means we're looking at the index. When it looks like this, nums of 2, that means we're looking at the value of that index. So right now we're at I equals 2, which means we're at index 2, which is this one right here. Now we're at nums of 2, which is the value of index 2. So the value of index 2 is a 1, which is equal to the value of index 0, which is also a 1, right? Boom, those are 2 1s. And then also the value of index 2 is equal to the value of index 3, right? Because this one is also equal to this one. Therefore, we're going to do R2 is going to equal 2 minus 0, which is 2, which comes from nums of 2 and nums of 0, and also plus 2 minus 3, which comes from nums of 2 and nums of 3. When we get the absolute value and add them together, we get 3. Boom. So that's where this 3 comes from right here. Then we're going to look at when I is equal to 3. So I is equal to 3 right here. We already know that there's a 1 here and a 1 here. So let's go through it. So when I is equal to 3, right here, nums of 3 is also equal to nums of 0. So once again, this 1 is also equal to this 1. And nums of 3 is also equal to nums of 2. So this 1 is also equal to this 1. So therefore, R of 3, which is index 3 over here, is going to be the absolute value of 3 minus 0, which comes from this right here, then plus the absolute value of 3 minus 2, which comes from this right here, which is going to give us 4. So we put a 4 right here at index 3 of R. Boom. Then finally, when I is equal to 4, R4 is equal to 0 because there is no index with a value of 2. So once again, when we're looking at index 4, there are no other 2s in this array, right? So there's no way for us to calculate a distance if there's no other 2. So we could just put a 0 right here. Boom. And just in case that didn't make sense, let's take a look at example 2. Example 2 is a little bit easier to understand because all of the values are unique, or distinct. So in example 2, we have our input nums equals an array of integers 0, 5, 3. Our output is an array of integers 0, 0, 0. Explanation says since each element in nums is distinct, R of I is equal to 0 for all I. Boom. So since each one of these elements appear once, we can't find the distance from another matching element or equal value. So since none of these elements are equal to each other, we could just put a 0 for each element. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult. Now, first thing we need to do is we need to get the number of elements. So we're going to say let n equal nums.count. Boom. Then we're going to map each value to a list of its indices in nums. So we're going to declare a variable called val2 indices. We'll set that equal to a dictionary int : int. So the key is going to be an integer, the value is going to be an integer, and we will, the value is actually going to be an array of integers. So let's put this value in some square brackets, and then we'll come outside both these square brackets right here, and we'll initialize it with some parentheses. Boom. Then we're going to say for I in 0 ... less than n. We're going to open up the brackets and we're going to say val2 indices square bracket nums square bracket I, come outside of that, but still inside the other square bracket we're going to say comma default : square bracket, come outside both of those square brackets, we'll say dot append, open up the parentheses, pass in I. Boom. Now we need to create our result array where ands of I will store the sum of the distances from index I to all other indices with the same value. So we come underneath this, declare a variable called ands, and we'll set that equal to an array. Open up the parentheses, we're going to say repeating : 0, count : n. Boom. Now we're going to process each group of indices that share that same value. So we're going to come underneath this and we're going to say for, open up the parentheses, underscore, comma, indices, come outside of that, we're going to say n val2 indices. We're going to open up the brackets and we're going to say let k equal indices dot count. Boom. Then if only one occurrence, then the distance is 0 and no other matching indices. So we could say if k equals 1, we could open up the brackets and we could just continue. Boom. Then the total sum of all indices in this group, we could get that by declaring a variable. We'll call it total sum. And we'll set that equal to indices dot reduce, open up the parentheses, and we'll say 0, plus. And what that is going to do is it's going to take all of the values in indices and it's going to start the count from 0 and it's going to add them together. Boom. Then we need the running sum of indices to the left of the current position. So we can store that in a variable called left sum, and we'll set that equal to 0. Then we're going to iterate through each index in this group. So we'll come underneath this and we'll say for I in 0 ... less than k. We'll open up the brackets and we're going to say let current ID IDX equal indices square bracket I. Boom. Then we're going to remove the current index from the total sum so it represents the right side. So we'll come underneath this and we'll say total sum minus equals current IDX. Boom. Now the contribution from indices on the left, for each I element on the left, we are going to get the sum of distances. So we come underneath this and we'll say let left contribution equal I times current IDX minus left sum. Boom. Then for the contribution from the indices on the right, we'll say let right contribution equal total sum. So this is going to be total sum minus, open up the parentheses, k minus 1 minus I. Boom. Then we'll come outside of that and we're going to say times current IDX. Boom. Then the total distance for this index, we're going to come underneath this. We'll say ands square bracket current IDX. Come outside of that, we're going to say equals left contribution plus right contribution. Boom. And then we're going to add the current index to the last sum, or excuse me, to the left sum for the next iteration. Excuse me, y'all. By coming underneath this, we're going to say left sum plus equals current IDX. Boom. Then we're going to return the final result by coming down here, and we can say return ands, y'all. Boom. So let's go ahead and give this a run. Make sure it runs properly. Okay, cannot find let sum. So let's add an F right here so it could be left sum. And let's run it again. Okay, cannot find current. Okay, let's get rid of one of these R's and run that again. Let's see. It's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 28 milliseconds beats 88.89% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.